This is what I used to do in the classroom. I just stand and wait until my students quieted down. You guys are good students, so thank you. Welcome to HASP this morning. I'm Sharon Nelson Arnsource, the president of HASP, and I'd like to remind you to turn off or mute your cell phones if you've not already done so. And we're very glad you're here with us today, whether you're here in the Jack or joining us via live stream. It's always a delight to have people join us. And now that we're moving into spring, welcome to a rainy April showers day. It means spring really is truly on the way. I've seen the little wildflowers starting to come up in my walks and the stems along Tulip Lane. So we've managed to make it into this part of the year. And part of this year is in April. This is our last month of classes for the winter-spring term, and I hope you will look ahead. There are many excellent courses that still have opportunities for you to join us, to continue to learn together in this spring season. You can follow the links in the HASP happenings or look online for the courses that you might want to explore yet this spring. And I also would encourage you to read carefully the HASP happenings every week to learn what's available each week, courses, and yet beyond courses. There are other opportunities. This past week's HASP happenings included some volunteer opportunities, some upcoming special events, Hope College offerings that might be of special interest to us. And then I noticed for the first time a very exclusive, private portraiture art lesson that'll be held for HASP members on April 20th. And this is being conducted by Grand Rapids artist Alec Zemper. And it says there'll be live models there. It didn't say whether the model was going to be nude or not, but you might want to check that out. Just saying. So with this excellent, up-to-date weekly HASP happenings, we have switched our newsletter from a monthly newsletter to a quarterly newsletter. And in April, you'll be receiving via the HASP happenings a link to the spring quarterly newsletter. And in this newsletter, there'll be some special articles referring to our upcoming 35th anniversary celebration, and other things that you don't normally see in the HASP happenings. So look for that. It'll be posted online toward the end of the month as well. At this time of every year, HASP members are invited to submit a nomination for an individual HASP member for the Distinguished Service Award. And this will be awarded at the June business meeting, the annual June business meeting. And the HASP member who receives this award is someone who's demonstrated a strong commitment to our lifelong learning organization through participation, leadership, and service. And information will be coming to you through the office as to how some of the qualifications and how to go about nominating this person and the due date to receive these nominations. So watch for that coming soon. And as I've thought about the Distinguished Service Award, I realize we have so many HASP members that deserve this recognition. So as I was thinking about it, I want to give it to all of you, but we don't do that. But I was thinking about what my daughter-in-law says about HASP. You know what HASP is an acronym, and we all know what that means. Hope, Academy, Senior Professionals. Now that's a mouthful. And some people think we should change the name. We just call it HASP at this point. My daughter-in-law says that acronym is confusing, and Hope Academy of Senior Professionals doesn't really explain who we are. She says that we'd be better served if we said we are the Holland Area Special People. So whether you receive a nomination for the Distinguished Service Award or not, know that you are one of Holland Area's special people. And I want to acknowledge all the contributions each and every one of you make in participation, leadership, and service to really make this organization great. And so now to welcome other special people. Our guests and new members this meeting is Membership Chair Doug Walvord.
Well, I like that special people line. What a great lead-in for the membership committee. Anyway, am I on? I have to learn to get closer, I guess. So anyway, we're very pleased this morning to have 3 guests attending with us, and I would like to welcome them by name. So attending this morning are Ron Steves, Eileen Hofstra, and Damian Zakakis. We're glad you're here. We're anxious for you to get to know all that HASP has to offer you, and we'd love to have you join us. Also like to welcome and introduce 4 new members. And if you would, I would like each of you to stand as I call your name, and just let us get a good look at you and make it easy for your fellow HASP members to welcome you as well. So joining us today, and also there are some that may be on online or attending online today, so obviously you're not going to see them. But our new members today are Joan Sanders, Tom Petrosky, Alan Denko, and Steve Van Dornick. We're very glad you're here, either online or in person, and anxious for you to jump in and get really involved in what HASP has to offer you. Also, as I say every month, please think of people you know who would enjoy and benefit from a HASP membership. We'd love to have them join us. Please talk to them and bring them as your guest to a monthly meeting. Thank you.
Good morning. I'm Marilyn Schmidt. I serve on the monthly program committee, and I'm very, very happy and pleased and honored to introduce today's speaker, Lindsay Olson. Some of you may recall she presented to us before, most recently in March of 2020, when her topic was Ocean Acoustics, the Art of Sound in the Sea. It was a fascinating presentation held at the Civic Center, and who could have predicted what would happen to our world a few weeks later? It was our last in-person meeting for quite some time. Lindsay has Holland roots. She was born in New York and spent her formative years in Huntington, Long Island, but her parents moved the family to Holland, where she spent her senior year at West Ottawa. She also attended Cope College for a couple of years, and then moved to Chicago and eventually continued her education at Columbia College. Many of you may recall her parents, John and Annette Daly. Annette was a HASP member. She resided at Warm Friend and sadly passed away in 2022. When not visiting a lab or working in the studio, Lindsay can be found canoeing with her husband Craig on one of Chicago's many area waterways, or riding a bike. The title of Lindsay's talk today is Art and the Elegant Universe. What are we made of? How did the universe begin? What secrets do the smallest, most elemental particles of matter hold, and how can they help us understand the intricacies of space and time? These are questions scientists and engineers at Fermilab, America's particle physics and accelerator laboratory, seek to answer. They are also the questions that inspired their first ever artist in residence, Lindsay Olson. Like a scientist's experiment, Lindsay's richly textured textile work thrives on uncertainty, curiosity, and a sense of adventure. By using her training as an artist, Lindsay draws viewers into her richly textured textile work and invites them to take a closer look at the world of high-energy physics. Her art projects require 3 ingredients: a commitment to learning accurate science, creating accessible art that explains the science, and using the artwork to promote physics in the wider community. In this presentation, she will share both her experiences as Fermilab's first artist in residence and what she learned about the weird and wild world of fundamental particles. In addition to her residency at Fermilab and over 20 years as a professor of fashion studies at Columbia College, Chicago, Lindsay's 15-year adventure of science art has included partnerships with the European Organization for Nuclear Research, the Metropolitan Water Reclamation District of Greater Chicago, the Field Museum, and the Center for Acoustics Research at the University of New Hampshire. Oops. Her work is currently touring in Europe. She has shown at numerous galleries and been featured in Scientific American, Physics Teacher magazine, and many other publications. She has also spoken at the Textile Society of America, the Studio Arts Quilt Associates International Conference in Toronto, the Field Museum, and many other venues. How fortunate are we that she has included HASP? Please join me in giving a warm HASP welcome to Lindsay Olson.
Thank you. It's a great pleasure to be with you all again. And Marilyn, my doctor assures me I'll be back on my bike in May. So I'm hoping that I'm not bringing any bad mojo again to this talk, the way I did in the March 2020. Yeah, who knew what was coming? But it's great to be back with you all, and I understand that some of you are in the physics camp, and some of you are in the art camp, and some of you are in all camps. So I'm hoping to sort of break down that artificial divide in the academic world between the sciences and art. So thanks for braving, those of you who are artists, thanks for braving the science, and ditto on the other way. So you already know that I have a long-standing practice of combining art and science, so my work takes me out of the studios to exciting places like this. Fermilab's cavernous ring of equipment designed to accelerate tiny bits of matter at near the speed of light. Here, scientists want to crack open the mysteries of neutrinos, and I want to explain it using art. Now, for many people, science seems like an insurmountable subject, and one of those people included me. But all of that changed when I realized that I could use my training as an artist to learn scientific concepts. So my husband and I bought a canoe, and for many years we would be going canoeing, and as often as he would allow me to, I'd be painting kind of impressionistic landscapes of the waterways in the bow, and he'd be paddling in the back. This did not last for too long. But my view of the waterway changed from this idealized view of the waterway when we passed this beautiful SEPA station. And I later found out it was an artificial waterfall designed to add oxygen to the sluggish canal. And finding out who built this structure and why would they build it in such an obscure location and spend millions of dollars on it, led me to the world's largest wastewater treatment plant in Stickney, Illinois. Now, this plant was built in the 1930s. Everything built in the 1930s was the world's largest whatever. So now treatment plants are much smaller and more localized, but this plant is like a kind of overwhelming place to walk in. So at some point in my trips to and from the wastewater treatment plant, I realized that I could learn enough engineering to tell the real story of water in a dense urban area. And I know it always sounds really strange, but this is like one of my taglines, is that I actually fell in love with science in the middle of a wastewater treatment plant. I know, weird, but true. So in researching places to show this extremely unusual artwork, I came across Fermilab's art gallery. And I thought to myself, they're a science institution. Maybe the wastewater treatment part of the art wouldn't bother them very much. And I sent off a proposal to Georgia Schwender. And I approached her about showing my artwork from the wastewater treatment plant. This is one of the pieces that I pitched to her in that talk. So she's taking me through the gallery, and suddenly she's explaining to me about, the kind of shows they have, and yes, she was interested in doing, a show about my wastewater treatment plant. She stops and she turns to me and she says, for many years, I have been thinking about having an artist residency at Fermilab. Would you be willing to be our first artist in residence and help me get it set up? So that was like a really big goosebumps moment for both of us. it took me 18 months of patient pestering to get into the wastewater treatment plant. So to have somebody ask me was really, really wonderful. So the second thought I had, however, was, oh my goodness, you have to remember this was only my second sci-art project, and I thought to myself, geez, this isn't even terrestrial physics, this is some like really weird, abstract, high energy physics. Could I really do this? Could I really learn enough science to make art that would be meaningful? So I'm known for leaping before I look. And so it served me well, so I said yes, and then got in my car and thought, oh my God, what have I done? But, I didn't really have much to worry about because Fermilab has a very long history of combining science and art, so they're accustomed to dealing with people who are outside of their wheelhouse. The first director of Fermilab was Robert Wilson. He himself was both a physicist and a sculptor. This is one of his sculptures. He made these enormous steel sculptures, and they're all over the campus, and some of you may have been there for a tour a little while ago. You can see them all over campus. Robert Wilson even thought that, the electricity poles were ugly, and he redesigned them to have these like really fabulous electrical poles. They're wonderful. In fact, Wilson's 11th hire at the gallery, 11th hire at the laboratory, was Angela Gonzalez, and she did what we would call today branding. She did all their posters for events and covers for their reports and so forth. She was a very gifted artist. And early on in my project, someone handed me a book by Dr. Don Lincoln. He's the senior scientist at the lab. And I took this book on vacation with me, and I puzzled over the first chapter. And I puzzled, and I puzzled. I think I read that first chapter like 20 times, because it's all about the standard model. And I thought if I can't understand the first chapter, I'm like dead in the water, so I was a little panicky. But eventually, I could absorb it, and through numerous passes through the book, I finally understood a little bit more. The standard model is to physics what the periodic chart is to chemistry. So on the periodic chart, all the elements are organized according to their atomic weight. And the standard model organizes life on the subatomic realm. That means things that are smaller than protons and neutrons. So this is what the standard model looks like to those of us without scientific training. Anyone who speaks the language of science knows that it's math-based, and this is what the equation looks like. And at the present moment, which is not to say it won't change, this is what, in this equation is buried all the information that scientists know about the nature of the universe today. So one of the biggest obstacles to learning about high-energy physics for me was accepting how particles behave in the quantum realm. It's really counterintuitive to the way that we perceive reality. And life in the quantum realm is so weird that you really won't need any illegal substances to completely blow your mind. It's true. So I struggled to learn this until I figured out I had to make room for both versions of reality. The reality that I learned with my senses and the reality of life in the subatomic realm. So one example among many of this dual view of reality is that things that appear solid to us, our bodies included, are not solid. They are made up of fields of wiggling, jiggling particles. So many artists use oil paint or watercolor or other traditional materials, but when I create my art, I want to figure out a way to have the least amount of distance between the viewer and the art. Everyone uses textiles in their daily life, so this seemed like a natural way to present a series of pieces for this work. So the study of physics is ancient, and I wanted to use colors that suggest antiquity. So I've included kind of high-end textiles like lace and silks, and sort of everyday workaday fabrics like denim and canvas. I also chose to include blackboard paint because, honestly, blackboards are everywhere. There's even a blackboard outside the ladies' washroom right next to the gallery. So, people who have conversations in math, they need to, have some place to do their notations and discussions. So I also use a lot of time-consuming hand processes in this piece, like beading and embroidery. And this piece is called Nuts and Bolts. It's a timeline of the discovery of particles. Now, historically, these kinds of processes like beading and embroidery were used on luxury clothing, and using these sorts of processes is another way to elevate the subject matter. So the standard model of particle physics has been hugely successful in predicting particles, including the Higgs boson, whose existence was experimentally confirmed in 2012. However, after years of correctly predicting particles, physicists know that the standard model really doesn't tell the complete story. So in this piece, I have a shortened version of the standard model that looks, if you were to see it more clearly, it looks like it's provisionally attached. And that's to suggest that new theories are going to be discovered in the future, we hope, and physicists hope. So I'm wanting to make my work stay current for as long as possible because the theories and my artwork may become obsolete. So after spending a few weeks working on these pieces, I brought them in to show Don Lincoln. And so I explained that I'd included all the particles and, you know, these are some of the ideas I included. And he's like going, okay, yeah, okay, that's kind of nice, all right. And then I said, now, can you find where I put the Higgs particle? And he's looking, and he's looking, and he's looking, and I said, I made them blend into the background. And he was like, oh my God, this is great. So the thing is that the Higgs boson was predicted over 50 years ago by a theorist named Peter Higgs. And it took 50 years for the engineering and the science and everything to kind of all get caught up to the culmination of building the world's largest machine, the Large Hadron Collider, to accelerate particles with so much energy that when you collide them, you can create the conditions under which the Higgs particles can be created. So having it look hard to find in the artwork was yet another way to underscore that science really moves slowly, and it's like step by step by step, and it's not just the theory, it's all the engineering, because everything at the Large Hadron Collider is custom built. There was no parts to build this machine. So during my residency, I was invited to join a group of scientists and artists at CERN working on the Art at CMS group. The Large Hadron Collider, as I mentioned earlier, is the largest machine ever built. And traveling to Switzerland to see this machine was very, very inspiring. It was really thrilling. The time that I went was June, and that's a very busy time at the lab. There's a lot of students who are visiting over the summer, and a lot of visiting scientists choose to visit. I wasn't able to have accommodations on campus, so they put me at a hotel that was slightly off the site, which meant that I had to rent a bicycle. I love biking. So my morning commute from the hotel to the lab was right past the Alps on one side and all the buildings of CERN on the other side. It was great. On my very first day there, the Art at CMS program held an exhibition at what's called the P5 site, where I set up my work, and I had a chance to meet with other artists and see what their work was on this. And it was really great fun meeting all of them, the scientists and the artists, at this event that they had. Now, the P5 site was chosen for the exhibition because just below our feet was the compact muon solenoid, the CMS experiment. And it's one of two giant detectors at CERN. The other is Atlas. I'm not supposed to, I think they're kind of competitive, so, you know, CMS paid my way, so I'm not supposed to mention Atlas, but they co-discovered the Higgs boson. So this particular experiment is 15 meters in diameter, it weighs about 14,000 tons, and there's 4,000 people from all over the world collaborating on this experiment. That's one of the really cool things about physics, is that they bridge political divides, religious divides, color divides. Everybody in the whole world works together on completely equal footing on these experiments. Before I move on, though, I want to point out, I think I have my little light thing here. If you look at the very bottom of this photo, you can see the teeny tiny humans. And so that gives you some idea of the scale of this experiment. So when I traveled to Geneva, I also had the opportunity to visit a book exhibition at the Martin Bodmer Library. They had a spectacular collection of medieval illuminated manuscripts. And these ancient texts were the inspiration for a group of pieces that I created on this trip to see the CMS experiment. So I had a kind of collision myself, not of particles, but of art and science with the illuminated manuscripts from medieval times. You have to think back to like when illuminated manuscripts were used. They were kind of the PowerPoint of their day, and so people conveyed very important information in them with both words and pictures, because obviously literacy rates back then were quite low. So what I wanted to do was create a series of unusual books that would help tell the story of our time about something very big and very important. So at first, this piece probably doesn't look like a book, but at the very center of that fan is a brad. And those are like skinny pages. Like if you go to the hardware store and you see one of those paint chip books, that's the book format I chose because it mimics the shape of the detector. In this piece, I have tucked in here, inside each one of these boxes, questions that physicists would very much like to answer. So a couple of those questions are, why do the forces have such disparate strengths and ranges? The strong force behaves in particles that are quite small, and gravity is like throughout the universe. Why is there more matter than antimatter? That's a big question. It's going to take some time to answer that one. Is there something smaller inside quarks and leptons? And one of the thorniest problems that people at Fermilab and elsewhere in the world are trying to figure out is, what the heck is dark matter and dark energy? Because all of the visible matter in the universe makes up about 5% of the mass. So here's a little close-up of that last piece. So in all of these pieces, I'm connecting the concept that the study of the tiniest bits of matter is intimately connected with the Big Bang and the origin of the universe. So in each of these pieces, I've also included references to the collision of particles and dark matter mapping. So when I got back to stateside after visiting Europe, I still had more work to do at Fermilab. And Fermilab is like the world leader in neutrino research. And neutrinos are a fundamental particle, and the universe is permeated with neutrinos. They come from the distant cosmos, they actually emanate from the Earth, they come from the sun, and they're manufactured at Fermilab, and the process begins with a very small bottle of hydrogen. These rarely interacting particles are also streaming through us, 1 billion of them, all the time. We just don't know about them because they don't interact very much with us or anything else. So in this piece, this is a textile piece that has organza in the background, and I've tried to create a kind of theatrical curtain to display a set of these particles. And they're very mysterious particles. I'm using 3 different shades of metallic thread to present these mysterious particles because neutrinos are really weird. They shift matter states. There's 3 different matter states that scientists know of, and I wanted to make sure that that information came through. You can see that here, that is my stand-in for the beam that generates these particles at Fermilab, and the circle is a reference to the, many-kilometer ring where these particles are accelerated. So my partner, Dr. Don Lincoln, I brought these pieces into him a little bit later on and showed him this one, and there's a close-up of that last one, and this piece. And I told him how many packages of embroidery floss that I used to create these pieces, and he figured out in his head, oh, that's like 3 miles of embroidery floss. That's helpful to have a guy with math skills on your team, right? So in both of these pieces, I'm using the metaphor of nets to suggest how detectors capture images of these elusive particles. And the art borrows techniques from high fashion. I wanted them to look glamorous and kind of mysterious. Some of you may have seen my wastewater treatment work, which looks very like, candy-colored toys. And again, I'm trying to overcome the yuck factor with that project, but for this project, I wanted it to look super elegant. So that's a close-up shot of that other piece. I was interested in learning about the science of high-energy physics, but I was also very curious about the experiments themselves. I was given permission to undertake rigorous radiation safety training in order to accompany the operators into the guts of this incredible experiment. And I wanted to learn about the people who operated them. So safety training is very serious at the lab. This wall of locks may look like the kind of locks you see underneath, the romantic kind of locks of love. And I call it the Fermilab locks of love, because each lock represents an individual human being and identifies their location in the facility, so that this is another built-in safety protocol for keeping everybody safe in the facility. So what I learned was this whole business of accelerating tiny bits of matter, accelerator science, it's really about riding a bucking bronco of particles. Now, the particles in the beam all have a positive charge, and many of you may have tried to put two positive ends of a magnet together. Okay, these particles are all positively charged, so they want to spread out like crazy. So in order to counteract that, engineers have figured out a way to place 1,000 superconductor magnets around the ring to steer and compress the beam. So they're traveling it near the speed of light. So at a certain point in this speeding process, once they are up to speed, they're released and they're shot into targets. Some of them are near to the lab, and some of them are as far away as North Dakota. And you don't need to build a tunnel for neutrinos because, as I mentioned before, they interact so rarely that they speed right through the Earth and hit the target. Don't ask me how they figured out how deep and where to place that target. It's in an old abandoned mine shaft. It's pretty amazing. And the reason we need this large machine and these big detectors is because neutrinos interact so rarely that you couldn't study them in one person's lifetime. This improves the odds of scientists to learn about neutrinos. So in this series of drawings, I wanted to create pieces that looked a little bit unstable, that looked kind of wild. So I'm using wet on wet ink, which is very difficult to control. I think it took me about, like 15 tries to get exactly the look I wanted for these pieces. It's a triptych. I've only shown the diptych because I wanted you to get a little bit of a close-up. But I used the Wilson Hall stage, much like this stage, to inscribe a 90-inch arc over the paper to kind of get a scale of an arc for the accelerator. My two absolutely favorite days on campus were, of course, the super exclusive tour of the neutrino facility, but also I had an open studio day at the lab where I brought my work in process, and I had a chance to talk to some visiting scientists and the scientists at the lab and some people from the community. And here I'm explaining about the accelerator division and why it inspired me. And the really cool thing about being a science artist is that I sometimes have scientists come up to me and they say, "This is the first piece of artwork I've ever felt like I could relate to." That is such a powerful thing. So not only am I an ambassador for the science at Fermilab to the public, but that I can be an ambassador for my profession as a visual artist. And that's a really wonderful thing to be validated. So there's a couple things I need to sustain me through the long arc of a project, especially one as terrifying as this project was. So I'm always looking for inspiration from visual images like many other artists. But you know, when my energy is flagging and I'm feeling a little discouraged, I need to think about finding creative heroes. And Dr. Ray Davis is one of my amazing heroic scientists. He really helped me. His story helped inspire me to keep going on this project. So Ray Davis was studying neutrinos, solar neutrinos that were coming from the sun. And he created this experiment to try to capture these particles. But his experiment yielded some extremely odd results. What he predicted, the number of particles that he predicted he would find in his experiment was like 1/3 of what he expected to find. So for decades, Ray Davis had to contend with his colleagues saying things like, "Oh, well, you know, maybe your math is off, maybe your experimental design is flawed." But once again, this vision of coming up with a theory, creating an experiment with what you have on hand, had to wait for the development of accelerator technology and different kinds of engineering skills and machines in order to be vindicated, because Ray Davis was honored with a Nobel Prize in 2002. So it's like all those of you who doubted my theory. So that must have been a really great feeling for him. I also look for other artists to find inspiration, and Lenore Tawney is a weaver, and she really stretches the medium to push it really far from what it is traditionally. So I've seen this work a couple of times at the Art Institute of Chicago. It's called Waters Above the Firmament. And the power of this piece owes its to the design. The circle within a square is a really, really powerful metaphor, I think. She's created slits in the finished edges in the center that appear to float in the air. And she uses acrylic paint to give herself total control over the placement and use of color. Also, that title, Firmament Above, I mean, who thinks of waters above the firmament, right? That's kind of a weird perspective. So in my mind, I was thinking, is she thinking hydrology or something spiritual? But that's the value of art, because every person looking at it is going to see something different. So Lenore Tawney carefully chose the papers she used to fill in the warp sections of the piece. And if you zoom in, you can see that she's chosen references to music, calligraphy, and text. And these texts reference our human attempts to understand the world. So Tawney inspires me to keep working to comprehend an area of science, understanding that this is so much larger than my own existence. Science and art are both very powerful ways to understand and appreciate our place in the universe. We need the rationality of the scientific method to move us forward in our understanding of life, but we need empathy and beauty from art to add dimension and meaning to our lives and to help us cultivate the right relationship with the natural order. I'm not going to talk about Christo here, even though he is one of my creative heroes, but I only have so much time. So to be successful, my projects need 3 key components. First, the artwork must be grounded in a solid scientific foundation. I am not interested in adding to the wealth of misinformation in science communication. So that's really super important to me. So I interview scientists and other staff members. I take tours, I take training, and I read deeply. And I design my projects as a full immersion experience. And out of that scaffolding, I create art that helps explain these scientific concepts. It's also important for me to have this struggle to learn something. Somehow in that struggle, that is key for me to learn the science and create the art. I don't know why, but I never have a problem with like the blank canvas that many artists do. I just need to dive into another science project, and it's like right there for me. That struggle is part of my inspiration. So the second key ingredient in having a successful project is that I employ all my training as an artist to make impactful images. And sometimes I have 3 seconds to snag the attention of a viewer. So it's really important to me to make sure that the art stands on its own. So if somebody wants to talk about just the art, that's great. If somebody wants to learn a little bit of science, we can do that. Or like those scientists who said, gee, you know, I'm really connecting with this art. That was great. So I tried to design it so there's like a little bit for everybody. That's me inscribing the art on the stage of Wilson Hall. Okay, so the last ingredient is that I have to obviously be passionate about my subject. So there's strict rules that define what activities get to be called scientific. But before an experiment begins, and after the data is analyzed, there is plenty of room to connect science to human emotion. So my goal is to lure in science-phobic people and with some handsome art and then blow their minds with cool science. So Fermilab was an extraordinary opportunity to work with world-class scientists and professionals. And one of the most powerful lessons I learned from this residency is that I'm not afraid to learn any kind of science, even high-energy physics. Both science and art are expressions that grow out of our humanity, and it's time to help spread the word about what science is learning about the universe. So we need to invite in poets, novelists, playwrights, singers, artists, and others to help amplify the message that science is an elegant necessity of modern life. And I want everyone to know what I figured out, and that is that you don't need a PhD to fall in love with physics. Now, that sounds like the end of my talk, right? I actually have decided that I would preempt your question, assuming that you would want to know what the current project is. So many of you heard my ocean acoustics talk, but and of course Manufactured River, the wastewater treatment project, but water has been a regular and passionate subject of mine, so I was delighted to be chosen as the first artist in residence at the Wetlands Initiative. Now, wetlands used to dominate our landscape here in the Midwest. They are powerful ecosystems that sequester carbon. They capture excess nutrients, they recycle nutrients, and they attract an incredible diversity of plants and animals. TWI develops innovative ways to use their engineering skills, yoked with an intimate knowledge of ecology, to create cutting-edge restoration projects. My inspiration for the project comes from a piece in the Metropolitan Museum of Art's collection. It's a fresh floral collar that was buried with king tut over 3,000 years ago. And the botanical specimens have been so well preserved that they can still be identified today. So I've chosen to create artwork in this format of a collar and use it as a metaphor to suggest that wetlands restoration can be thought of as a kind of ceremonial garb, honoring our partnership between engineering, ecology, and natural processes. So this is not finished, this is works in progress. I began my work in the Calumet region, which is at the very southern end of Lake Michigan. Here, TWI is conducting a floristic survey at Indian Ridge Marsh, and I was helping along on that day too. The incredible thing about this site is that they're restoring a wetland on top of slag, which there's no end of slag in that area from the steel manufacturing. So it's an industrial waste from the steelmaking process. Since geology drives floral diversity, this is a stunningly original project. In the heart of the Illinois Corn Belt, TWI works with farmers to reduce the flow of excess nutrients and fertilizers from farm fields and into local waterways by helping them construct wetlands on the farms. So I'm working on a couple of pieces related to TWI's established conservation efforts at Medewan Tallgrass Prairie and their jewel in the crown of restoration, the Dixon Wildfowl Refuge. So I'm excited to be working with a bunch of dedicated professionals. I'm having a great time with them and creating this new art, and now it really is the end. So this is actually my favorite part of a talk, is Q&A, so I'm happy to take questions. So thank you for being. Okay, so you know, a speaker's all big nightmares. Oh my God, do they have questions or not? You never have this trouble with fifth graders, ever.
Yes, in one of your slides of where you said the background had the boson Higgs hidden in there.
Yes.
Could you back up to that
Yes.
slide and kind of use your laser to show me where it's hidden?
Certainly.
That'd
You
be
know,
great.
this like kind of low res, there's a lot of light in here. If we could we lower the house lights for just a moment? Then you can bring them up after we look at the Higgs. Obviously, it's not just Don who had a hard time finding the Higgs particle. Okay, so using my laser, you can see the H's. Camouflaged, wasn't that sneaky? It delighted me no end that Don couldn't find them. And they're on all the pieces, all the standard, I made 6 of these, so they're on all the standard model pieces. And on one of them, I have the Lagrange equation actually embroidered out. And somebody, like two young scientists came up at CERN and they're like, that's the Lagrange equation. They were like so delighted.
Good morning. Oh, here. Hi.
Yes.
Thanks for being here. This is fascinating.
Oh.
How much time did you spend at Fermi?
Since I was the first one, I had the luxury of being there for 2 years. Now it's only 1 year. But at the end of the year, I told Georgia, I said, you know, I still have a bunch of work inside of me, especially after that trip to CERN. She said, just keep making work, just keep going. So I had 2 years of work there. Is there a question back here? Oh, over there. We'll get to you.
Thank you. I want to go back to the Fermilab and your work there, but will preface by saying I've probably seen too many Star Wars and Star Trek movies.
Same.
But I have seen every now and then a news feed claiming that scientists are certain we will break the mystery of faster than light acceleration. Any comment from your discussion with the scientists on that?
Is there a doctor in the house? Is there a different kind of doctor in the house? You'll have to take that to the science community because my range of knowledge is very, very limited. But isn't it incredible, though, how physics can bring up all these insane questions? They're just like, there's nothing but questions. It's so exciting to be working on the edge of our knowledge. That's what basic research is. It's not research for a particular purpose or coming up with a solution. It's finding the frontier, the very edge of our knowledge and pushing it. That's what makes the research at Fermilab and CERN so exciting.
The science that you're talking about is like all math. And so I wonder, when you're engaged in your artwork, is there ever, or to what extent are you concerned or thinking of math as you do your work?
Not at all. Okay, so I have not missed the science bus, but I think at my age I've missed the math bus. So my current math is limited to balancing my checkbook. That's challenge enough for me. But you know, it's interesting that it isn't just the math, which was what was kind of making me nervous in the beginning of the project. There's like theoretical physicists, and then there's the physicists called experimental physicists. And the people who are experimental physicists, they're the people who like to work with nuts and bolts. They like to solve the problems of creating the world's largest and fastest accelerator, or the piece of equipment that you need to get a little bit better resolution on those collisions. So I really loved, I spoke to the theorists, but to tell you the truth, the theory was often way over my head. With the experimentalists, I at least had like, I could probably understand like 10% of what they were telling me. And I can do a lot with 10%. So could you.
Yeah, I have a question. These fundamental particles are, they have neither form nor shape, but they have mass.
Yes.
As a visual artist, how do you portray that?
Yeah, so this is like the weird thing, right? Is how do you make tangible something that is intangible? It was the same with my ocean acoustics project. How do you make sound, which is not visual, how do you turn that into visual art? So that is my big challenge, and for some weird reason, that is what I like to do. So, you know, I maybe made the neutrinos into threads to sort of emphasize their travel time, their movement through space and time. So that was one way of getting those neutrino particles to look like something. And the beam is it's like a big unicorn tail. I would never tell this to the scientists, but they were like, what? What? But that big ponytail of threads, that was my stand-in for the incredible, powerful particles that are being speeded up in the accelerator. So it's like, and then of course, each of the particle has a name. So I used the initials for them, like on the standard model. There's, you know, E for electron and, you know, muon neutrinos, tau neutrinos, electron neutrinos. They all have a name. So I can use that symbol in my work, too. So that was kind of a, yes, finally.
Do you have any of these images in a book or a computer visualization so you can see them up close and
Yes, I
appreciate
have
them?
a website, LINDSAYOlsonArt.com. And if you don't remember the .com part, just put Lindsay Olson, Fermilab, and you'll see a lot of stuff. There's my website, which has all of my projects and all of my work that will look a little better than this. These are sort of blown up.
Just thinking about the art, and have you looked at Leonardo da Vinci's diaries? Because
Yes.
his artwork as a scientist was amazing for his time.
And as an artist as well. Leonardo was like the most famous sci artist there is. Yes, thank you, I have. I would love to go and see them in person somewhere. That's like that would be a pilgrimage. He was brilliant.
Can you say a little more about dark matter?
Okay, so dark matter was not something that I investigated while I was there, but the reason that scientists know that there is more out there than visible matter, the reason they know that there's like of the 100% pie of matter in the universe, visible matter is like almost 5%, which is what we can see as planets and stars. The rest of it they know is there because of something called gravitational lensing. And gravitational lensing is about a phenomenon that happens when light is bent by gravity. So they know there's more mass in the universe than we can see. We just don't know anything about it. So again, we need to refer to the doctor in the house or the doctor at Fermilab to explain that in greater detail. But that is the extent of my understanding.
Do we have any more questions for Lindsay? Well, Lindsay, I want to personally thank you for coming back and visiting with us again, and for bringing your passion for art and science to us and helping us see through the eyes of an artist scientific exploration, I should say.
Thank you so much.
Thank you.
It's a great pleasure to be here.
I would like to remind you that next month, which will be May, we will be having Dr. Roger Bauman, who is an associate professor at Hope College. And Dr. Bauman is going to be helping us to understand what does the term Christian nationalism mean. So if that is of interest to you, please join us. We hope to see you in May, and we will then, of course, see you in June for our annual meeting. But I did hear the birds this morning. It did feel that there might be spring is on the way. So what do we say? April showers, bring May flowers. Have a great day. Thank you.